To create toolpaths for reliefs, the toolpath used is the Machine Relief toolpath. This is located under 3D toolpaths. This will open up quite a basic dialog. I'm going to leave the area to machine as the whole relief. The first thing that I'm going to do is set up a finishing tool. Now you would normally use a ball nose for this, as it will give a much better finish as it passes over the contour of the relief. I'm also going to select a roughing tool, where you would normally use an end mill or a slot drill for this, to basically remove as much material in preparation for the finishing tool. For this example, I'm just going to use the largest tool that I have, which is a 12mm end mill. As with any other toolpath, you can select the blue area on the tools to access their parameters, and this 12mm end mill has quite a large step down, so I'm going to change it and select Calculate Now. This will calculate the roughing toolpath and display it first in red, and then calculate the finishing toolpath. Once calculated, the toolpaths can be turned on or off using their light bulbs in the project tree. A quick tip: if you right click on a light bulb, it will turn off all the other light bulbs and turn on the one that you right clicked on. If you zoom in on the relief, you can see that the red toolpath lines follow the contour of the relief. I'm now going to right click on the roughing and simulate just that toolpath. You can see that it vaguely looks like the relief because it is just roughing the part out. The allowance is set to 0.5mm, so that is what has been left on the material for finishing. If I simulate the finishing, you can see that it is much closer to the finished relief, although there are some areas where the tool just can't physically get in, and the only way to overcome this is to use a smaller tool. Now let's delete the simulation and take a look at the finishing strategies available. There is raster, which I just used, which will follow the contour of the relief in X, step over in Y, go back in X, and then step over in Y until the relief is machined. Raster X and Y will basically do two rasters, one the same as the normal raster, and then rotate 90 degrees and do another raster. This does give a better finish, but bear in mind that it also doubles the machining time since it's doing two separate rasters. There is also a spiral, which spirals the toolpath outwards and gives a much better finish for this type of relief. I'm now going to calculate this. It would normally take a couple of minutes to calculate this, so I'm going to speed it up slightly for the sake of the video. If I turn off the visibility of the roughing toolpath, you can see just the spiral toolpath. Zooming in, you can see how it spirals. If I change the step over, you'll see the spiral change. You may notice that the spiral toolpath has not machined the whole of the relief. This is because it spirals outwards, and as soon as it touches the edge of the model, it finishes. If I choose the spiral in a box strategy, it will then machine those areas, do it within a box, which is basically the whole of the relief. Now the first option in the Machine Relief dialog is the area to machine. You can change this from whole relief to automatic boundary or selected vector. The automatic boundary will create a boundary from the relief when calculating. Again, I'm going to speed this up in the video as it will take a couple of minutes to calculate. You can see when simulated that this just machines the relief and not the whole of the model. I can also use selected vectors. This is useful if I want to contain the toolpath to a certain area. For instance, I've created this polyline in the centre and this is my boundary. Select the vector and make sure that selected vectors is selected for the areas to machine, and when simulated you can see that the toolpath is contained to this vector.